Okay, so I'm going to talk to you a little bit about exponents, particularly fraction with variables that have exponents, negative exponents and positive exponents, and how to handle them. So let me just jump to this example here. How about p squared times q to the negative 3 times r to the negative 4 times s to the 0 power all over p to the 5th times q to the negative 6th times r to the 7th times s to the negative 8. Okay, well, this is a relatively easy problem. One thing here I notice that the s to the 0, that's just 1. Okay, anything to the 0 power is always 1. And the reason for that is because if 1 is equal to a over a, then a over a is a to the 1 over a to the 1, which is equal to, now if I was to bring this a down here and move it up to the top, I'd get a to the 1 times a to the negative 1. And when you have like variables, you add the exponents together, so you get a to the 1 plus negative 1, which is equal to a to the 1 minus 1, which is equal to a to the 0. Okay? And so this is the same as that. Alright? So, let's continue here. When you're working with fractions and you have negative exponents, you want to make them positive, so what you do is you take the variable with the negative exponent and move it to the top. Okay? When you have variable with positive exponents, you basically take the smaller exponent and move it down to the bottom. So in this case here, if you move the p squared down, it's going to turn into p to the negative 2. Since the p to the negative 2 would be at the bottom, you would just add 5 and negative 2 and you'd get a positive 3. So let's do that. So we're going to get p to the 5 minus 2 would be p cubed. Okay, so that takes care of the p's. And q to the negative 3 over q to the negative 6. Well, again, you take the smaller exponent and move it to the larger exponent. I'm pointing at the negative 6, and the reason why is because on a number line, negative 6 would be smaller than negative 3, because as numbers go in this direction, they become infinitely smaller, and as numbers go in that direction, they become infinitely bigger. Okay, so knowing that, you take the smaller number, which is negative 6, move it to the top, and the negative 6 becomes positive, which means that q will be negative 3 plus 6, which will be q cubed. So r to the negative 4 goes down because it's smaller, and that becomes r to the 7 plus 4, which will be r to the 11th, and s to the 1 is just 1. And s to the negative 8, well, you move the s to the negative 8 to the top, that becomes s to the 8th. And that makes your final answer q cubed s to the 8th all over p cubed r to the 11th. Okay? And let's see, let's do one more problem. Alright. Let's make this one a little more difficult. What if we had a, b, c over a, b, c, and you had negative 2, negative 3, negative 4, 5, 4, 3. And we're going to raise the whole thing to the negative 2 power. Well, let me show you something real quick here. Whenever you have p over q, let's just say, raised to the negative n, which n represents any real number, this turns into q over p raised to the n power. So you flip the inside, switch the sign of the exponent. Okay? So over here the n became positive, but that means that the inside flipped. So p over q turns into q over p. And then that you can distribute the n to the q. You get q to the n over p to the n. I hate using the word distribute, but for right now, that's just what you could call it if you want. Okay, so in this case here, I'm just going to tell you there's a couple things you can do. You can distribute the negative 2 to each and every one of these exponents, which means that some of them, negative 2 times negative 2 will turn into positive 4. You can go about it that way. And or what you can do is do like I said over here, you flip the fraction on the inside. And let's just go ahead and do that. Let's just flip the fraction since I mentioned that earlier. So if I flip the fraction, this is going to turn positive. So when I do that, all I do is I copy things over. Okay, a to the 5th, b to the 4th, c to the 3rd, a to the negative 2, b to the negative 3, c to the negative 4. Okay, and now I go ahead and distribute my exponent. And the justification for that is this. Whenever you have p to the n raised to the m power, that's equal to p to the n times m. Okay? So I'm going to get a to the 5th, and a to the 5th raised to the 2nd power is going to be a to the 5th squared, which is a to the 5 times 2, which is a to the 10th. That would make this b to the 8th and c to the 6th. And on the bottom, you just multiply the exponents. A to the negative 4th, b to the negative 6, and c to the negative 8. Okay? And now, that would be equal. This is something else here. So now let's continue from here. Like we did with the previous problem, negative 4 is smaller, bring it up to the top. A to the 10 plus 4, because as you move the negative exponent to the top, the variable with the negative exponent, this thing becomes a to the positive 4 up here. So when you have a to the 10th times a to the positive 4, it's a to the 10 plus 4, which is a to the 14th. And with the b, the negative 6 is smaller, so take it to the top. So you'll get b to the 8 and 6 would be b to the 14th. And c to the negative 8 is smaller, so you take it to the top, that becomes c to the 14th. And we didn't really need this division bar here. But in that case, this would actually be your final answer. A to the 14th, b to the 14th, c to the 14th.